All right, I'm going to get started. We're going to go over Chapter 5 today, and we'll go through some examples. I'll give you an example to work on in class again on Wednesday, as we have been doing, and next week will be lab, all right? Which means the week before break, which is 2 weeks from now, we will go over Chapter 6. So we'll be through the first 6 chapters by the time we break. The week you come back from break, that will also be a lab for this class. All right. So I think I'm on around, if this is maps up with a book, around page 269, Chapter 5 on methods. This is where we start between chapters 5 and 6. We start to really transition over. In this chapter, what you learn is you cannot put everything in main. And again, ideally, main will be a driver that may call one or more functions to start the process, but it won't do everything. All right? So what we're talking about is modularization. I don't want to read to you. This chapter is on methods. A method basically is the same thing as a function, but unlike a function, a method really is built inside of a class. All right? So we've worked with methods before, but the only one we've really worked with has been main. That's the only one that we've written. We have worked with a bunch of other methods, and the author mentions some of them right here. System.out, integer.parseInt, etc. So it's not exactly like they're new. What you are allowed to do, or what you do with methods, is you start to modularize a program. Maybe you remember back in the day with me, it was 4th or 5th grade, the first time I had to write a book report, and I had to write it in an outline form. You know, when you had your Roman numerals, then you broke it down into your letters, and then into your numbers, etc., and you went from the very general to the very specific. That's kind of what we're doing right here. In an ideal world, what you're doing with methods is you're taking a job and you're separating it into subtasks, and each one of those subtasks will become a method. The author mentions in here that it's also known as divide and conquer. All right? It goes by a lot of different names. So what they say in here is, well, rather than having to sit there and write something sequentially like this, especially if it's doing a bunch of different jobs, you're much better off writing it like this. All right? And again, you'll see that as we go on. The thing with methods is, remember that any method in a Java program can either return nothing or it can return a single something. All right? If the method returns nothing, you have to go and say that that particular method is a void method. In other words, you have to put void in there for the return type. You don't need a return statement if it's void, although you can put one in. If it returns anything other than that, you have to let the system know what it's returning. The author calls it here a value returning method. All right? Now, we've looked at this kind of thing before. Again, this right here is our method header. So we've got public, and we're going to be getting into that in more detail in just a couple chapters. Static, all right, meaning there's only one of them. Void, meaning main does not return anything. Main is the name, and you can optionally add a string array that's called args. But you'll notice what's missing in here is there's no return statement. There is no return statement because the return type has been defined as being void. All right. And he goes into it, I guess. I could have done that, but on 272, he goes into everything that I just went over, okay? And when you call a method, if it's a void method, you don't assign it to anything. If it's a non-void method, you must assign it to something. You'll see that in just a couple minutes. You should be able to follow this, although sometimes Gaddis has a tendency to write a code that's a little bit convoluted, but you should be able to figure out what's going on here. You're in main. So what should print on the screen here is hello from the main method. Then you call display message. What that literally means is control of your program now goes from main down to here, where it does all this. So it says hello from the display message method. Then it hits that curly brace, then it jumps back up to the next line. So the output should be hello from the main method, hello from the display message method, back in the main method. And if you look on the bottom of the page here, that's exactly what it shows you. I mean, the example, like I said, is kind of stupid, but it starts to show that you can have a method that can call other methods. He walks through it and he shows you exactly what's happening. And it's the same thing that I just mentioned. Another good reason for writing a method, and again, the example is kind of dumb, but you get the idea, is rather than having to write the display message 5 times, because they're calling it 5 times in here, you write it once and you call it from within a loop 5 times. So this should say hello from the display message method 5 times, because we're telling it to call it 5 times. All right, and there's 3 of them. There's the other 2. All right. Okay, then he comes in and he actually looks at a method that's not too bad in here. But again, the idea, the thing to start thinking of is we don't want to put everything inside of main. So he's weaning you away from main. He's still got quite a bit of stuff in this particular particular example, because this is main right here. It starts here and it goes all the way to the bottom of the page here. So 30 some lines. But you'll notice that what it does is he calls qualify or he calls no qualify. And on the next page, those are those 2 methods. And it's pretty simply done, but he could have modularized this even more than it was modularized. All right. For years, I've taught C programming here, and C is a language that's still used a lot. It's like a 50-year-old language, but it's still used all the time. The thing is, typically, what I tell students is if you write a program in a language like C, which is non-object oriented, and you've got 500 lines, you'll typically have 10 functions of about 50 lines each. But when you write in Java, if you write 500 lines, you'll typically have 50 functions, 10 lines each. So you start to see the idea when you work with an object-oriented language, all right, is that you have a lot of methods that are very small. Ideally, each method will do only one thing. So in this case, qualify. And all this is doing is it's printing out a message saying you qualify for a credit card. No qualify, which just prints out a message that says, sorry, you don't qualify for a credit card. Now, the author could have taken the stuff on the previous page, all the stuff that's up here, and could have written 1 or more methods for that as opposed to putting it into main. He didn't, but he very well could have. All right. So he goes into this again. So what does he do? He has main. And main prints, I am starting in main. Main calls deep. Deep prints, I am now in deep, which calls deeper, which prints, I am now in deeper. And again, the idea, what he's showing here, the ideas are good. The example is kind of silly in itself, but you should be able to figure it out without looking at the actual output, that it should say, I am starting in main. Then it should say, I am now in deep. Then it should say, I am now in deeper. Then it should say, now I'm back in deep. And then it should say, now I'm back in main. Just so you can see the progression of what's going on in here. There's goods and bads about modularizing programs like this. The good is that if you separate your program into a bunch of little mini programs or methods, etc., and you have a problem, all right, the good thing is, ideally, if I know there's a problem that's in deep, that's the only place that I have to look for the problem. All right? So ideally, that's why you modularize. But typically, when you modularize and you call and you keep calling routine after routine after, it's going to slow the program down. You may or may not know this. I may have told you this before. I may not have. You may have heard it from Denny. I don't know. But literally, when this gets called right here, what the system has to do is it has to keep track of exactly where it was in this function, just in case, or in this method, just in case there's an error in this method, so it can jump back again. And it has to do all that stuff, for lack of better words, automatically for you. So what it does is it copies everything that it had in main up into an area of memory that's called the stack. All right? And then it goes in here and it starts doing its thing, and it says, oh, I got to call something else. So it copies everything that it has here to the stack. Then it goes down here and it does this. Prints that out and it says, oh, I have no more to do. So then it comes back here and it's got to grab everything that was on the stack and basically put it back to where it was. Then it does this, it says, oh, I'm done. So it's got to go back again and do this. The reason I'm telling you that, I may have mentioned this to you before, is when you're working on a program and you get an error, a lot of times what it'll show you is a list of the functions that have been called thus far. And that's known as a stack backtrace. That's what the program is doing. The documentation comments, there's other stuff that you can write. We're just not going to get to that right now. That's not a big thing. All right? So what they mention is some of the methods that you've already used, system.out.println or integer.parseInt, you have to have provided a parameter, one or more parameters. All right? So if you look at this example, again, it's kind of a silly example because all it does is it does a system.out.println and on whatever you passed in. So if we call display value and we pass in 5, 5 becomes num. And it says the value is 5. Just a couple things, and you've heard this stuff before. It's void, so there's no return statement. You need to pass in an integer. So that whatever that value is in there must be an integer. The easiest ways to break a program is to break those rules. All right? The compiler is looking for all that stuff. And if it finds something that it doesn't understand or something that's out of whack, it's just going to stop the program right there. Here they're showing that you can call the same thing and pass it different things. Here they're passing it a literal value. Here they're passing it a variable. Here they're passing it a variable, but first, they're multiplying that variable by 4. And here they're passing it a string, but since it has to be an int, they're doing an integer.parseInt on it first. So again, there's a lot of different ways that this can be called. They all work. Notice that when you call a routine like this, don't put the type in there, not on the call. So if you're passing in X, do it like this, don't do it like this. However, when you declare it in the routine, then you have to put the type in. It's just the rules of the language. And every language has got their own little idiosyncrasies, their own little ways of doing things. And they mention that this, when you call it, is typically called an actual parameter, and this up here is typically called a formal parameter. You've heard this before. The actual parameter must be its name. The formal parameter, you can call it whatever you want. And again, they get into the type compatibility. I've already mentioned that to you. Now, the thing with scope, the key thing here, and you've heard this before, if I define a variable inside of a routine called showSum, right there, this variable called sum, this variable comes to life right here. As soon as that is hit right there, that variable dies. And when I say it dies, what happens literally is the system lets it know, okay, the memory that you're using to hold that variable, it's not needed any longer. Okay. Here you notice they're passing in 2 variables. So num1 and num2 better both be doubles. You can say, well, they weren't doubles, they're integers. As long as they're declared as being type double, you'll be fine. All right, one of the things that you'll go over next year or a year from now is you'll be talking about a language called Swift. With Swift, that is one of the most literal languages I've ever seen. It's the language that's used for iPhone apps. There, it's real easy to break something. There, if I didn't pass this in as 5.0 and 10.0, the program would blow up. All right? And again, he does a nice job here, he being Gaddis, of going through and showing you exactly what's happening in here. And you'll notice that virtually every example we've seen thus far, the return type is void. Doesn't have to be that way. All right, but so far, just about everyone was. You'll notice again, if you've got multiple variables, you can't do that. You have to put the type every time. So the number must match. So if I'm passing in 3 variables into showSum, I must have 3 variables in here. And if they're an int and a double, for example, then that must say int num1, int num2, and then maybe double result or double something else. When you work with primitive types of variables, and by now, this should be second nature to you. Again, we've got what? Byte, short, int, long. Those are our 4 whole number variables. Float and double. Those are our 2 types of variables that can have decimal places. And char and Boolean. Every one of those 8 types is passed by value. What that means is a copy is passed. So if you do happen to change the value that gets passed in, you're changing a copy. You're not changing the real thing. Java, unlike C#, unlike most other languages, Java does not provide a way for you to go in and pass a variable in like this and change it in a method. All right, because all primitives are passed by value, you can't change that. Even if it's an array, which we haven't looked at yet, but we will in a few weeks, if it's an array, if you pass the entire array in, you can change it. But if you only pass one element of an array in and you change it, it's just a temporary change. So the bottom line is you should get used to, since it's passed by value, you should get used to not doing things like this. If you're passing in my value, you shouldn't change it. It's not that you can't, but any change you make, as soon as you go back into the function that called it, it reverts back again to its original value. So you'll see in here it says it's 99. Then down here, it'll say that it's 0, but when it gets back to the calling function, it'll be 99 again. And that's exactly what you see right here. All right. Again, if you pass an object in, so if I pass in an array or a string or whatever, that can be changed, because those are not one of those 8 types. So as long as it's not one of these and you pass it in, it's considered an object data type. So any change you make to it is a permanent change. And he gets into this, but it's kind of important that you at least realize what's going on here. That if you do this, if you pass a string into a method, what he's showing you is you're not passing in that string. You're passing in the address in memory of where that string is. Since you're passing in the address, any change you make, again, is a permanent change. All right. And that's what he shows you in here. And in here, for that matter. These parameter tags, again, I've got to put an example of that out there. It's not really that important for what we're doing. So I'm just going to jump up all the way to section 5.3, which looks like it's page 291. Local variables. We've already talked a little bit about this. If you define a variable inside of a method, the variable is local to that method. So you see, what we have here is we've got, and again, the example's kind of silly, but in Maine we call Texas and we call California. And you'll notice that in Texas, they create a variable called birds. And it says, in Texas, there are 5,000 birds. Then in California, they create another variable called birds. The point is, those are 2 distinct variables located in 2 different areas in memory. So they can have the same name. All right? And although you typically should not do this, just to show you this, another thing that you actually can do in this language is you can come in here. For instance, if I were to come in and have public class hello, kind of a dumb name, but just so you get the idea here, and I came in here and said public static void main string bracket args, and I came in here and said int age equal 21. All right, then I said I'm just going to call a routine here that says whatever. All right, and now I've got in here The point is, those are two different ages. In fact, what happens is this age that you see right here is said to shadow this age right here. You can't even, when you're in here, you can't even get to that age anymore. They're two different variables. Now, in some languages, you still can by putting super or putting something in front of it, not in this language. All right? So you say, well, how do I get around it? Don't call them the same thing. All right? That's the shortened version. And again, I think we've mentioned this before, but if I come in here and I come up here and I type in int var equal 33, that variable, since it's been defined outside of any routine that's in here, var can be used in here, var can be used in here. All right? If I wanted to have this age right here be actually used in here, okay, then what I could do is I could say age equal whatever, then this would have to change its type to an int, and I could call it int. I don't have to call it age, I can just say a. And I could say return, for example, a equal 50, return a. Now I have changed it. And if you follow what's going on here, in fact, I can't do it like that. There we go. Now I'm saying age equal whatever, and I'm passing it in that. So it's passing it in, it's passing in a copy in there, 21. All right, so wait a minute, you said we can't change it. We're not doing it the same way. We actually are returning a value. Would you want to do that? It's a way you can write code. All right. There's always a lot of ways that you can do the same thing. Doesn't necessarily mean that that's a good way of doing things. It's a way of doing things. What you're going to see after the break is we're going to go and look at the payroll example and one of those test examples that I wrote. We're going to see how to take those and modularize them. As it says, it's possible that to use a parameter variable to initialize a local variable. Yeah, you can do. There's all sorts of different things that you can do. All right, so we've got here double sum to hold the sum. Sum equals num1 plus num2. In fact, let's look at this example. This is the example that the author just put in here. Oops. All right, we're not returning anything. You all see that. It's type void, okay? Now, why did the author do this and say double sum as opposed to doing this? I don't know. I would have done it that way. But what he's saying is you can pass in values to a routine and use those values to go and initialize another value. All right? What you're oftentimes going to see is rather than something that looks like this, you're going to have something that looks more like this. This will be an int, and I'm just going to call this add2. All right? And then what you'll do, I don't want that to be int d. All right, and let's just make these ints. So I want to add these two variables up. I could do this. I could say int sum equal num1 plus num2, return sum. That's totally legit to do that. But it's more work than I have to do. I could just say instead of this, which is okay to do, I'm much better off just writing it like this. Just like that. So I'm passing two values in this case, all right, in this case, I'm actually sitting there and declaring a new variable. And I don't know why I would do that. All right, but I could. That's the point, is if we wanted to, we could. So there's a lot of different ways always of doing the same thing. That's the point. All right. Methods, again, you can return a value from a method, only one. But as you'll see as we go on and we write more complex apps, that one value that you return can be one array, or it can be one object that holds a whole boatload of stuff, but it still is only one. Again, if you say that you're going to have a method that's going to return something, you've got to put the return type in there. That's the key thing. And you need a return statement in there someplace. All right. This is very similar. I guess I should have shown you that one. That's very similar to the example that I just showed you. All right. So what are you doing? You're getting two numbers passed in. They're both integers. You're returning the addition of those two numbers. Since you're returning the addition of an int plus an int, the return type must be an int. Okay. And again, as they say, if you don't do that, Java's going to throw an exception. It's going to tell you you did something wrong. So they've got a very simple little thing in here that it goes through the same stuff we've just done. All right, you assign a couple values and you pass it to a routine and it comes back, the sum of 20 and 40 is 60. Okay. Again, if you have any problems with any of this stuff, I would strongly suggest that when he's got these in the Spotlight programs, like the one he has right here, that you take a look at them. You can return any kind of value, including a Boolean. So he talks about that here, returning true or returning false. All right. You can return strings. Again, you can return anything. You can even return a reference to an object. All right. So what they're doing here, and this is a little bit advanced because we haven't gone into some of this stuff yet, but the point is they're returning a string that's combining the first name and the last name. Okay. This goes to what I mentioned before. I'm not going to read this to you, but they're talking about the divide and conquer mechanism. All right. You know, I've told this to people before. Maybe you've heard me say it in other classes. I don't know, but it's like when you get home. You know, I remember when I moved out of the house, I lived alone for a while. You know, and I lived in a small place. You'd get home, but even if it was a small place, there's way too much to do. I don't want to clean this. So you started kind of dividing it into tasks. Well, I can do this. Well, I can do this. If I complete all the tasks, I'm still doing everything I wanted to do. But rather than looking at it as one unit, I'm looking at it as different tasks. And that's what the author talks about here. It says, let's look at an example. The code listing reads 30 days of sales amounts from a file, displays the total sales and the average daily sales. So they're saying that at a minimum, you'd probably want to break that down into 4 routines. Ask the user to enter the name of the file, get the total of the sales amounts, calculate the daily average, and display the total and the average sales. All right? So again, what you're doing here is you're writing more and more, all right, modularized code. He still isn't quite there yet because really he's doing this inside of here. I guess he does have a routine called get file name. He's got another one that's called get total sales, but he really could have also done this where he does the average. That could have been done in its own routine. All right, again, as you work with object-oriented languages, you're quite often going to write very small routines that only have 3 or 4 lines in them. All right. Calling methods that throw exceptions. You're going to see some of this. We've seen a little bit of it before. We've looked at the throws IO exception. You've looked at that before. You may or may not remember it. But when we brought files in, we had to put in the main throws IO exception, because it's possible that you could try to be reading a file that isn't there or whatever. Okay? That won't change. And that's it. This is a short chapter. Okay? So what I'd like to do is I'd like you all to get into Eclipse right now. And what we're going to do is we're going to just make a couple changes to the last version of the payroll project that we worked on. All right, so we're going to make some changes to that. And then after the break, we'll take a look at some other stuff. So what I'd like you to do is bring up Payroll 04A was the one I called it. You may have called it something different. But I'd like you to bring that one up, the first Chapter 4 payroll one that we did as a class. So what I'm going to do is I'm going to grab everything that's in that program, and I'm going to copy it to the clipboard, and I'd like you to do the same, please. So literally grab everything that's in that payroll for Chapter 4, copy it to the clipboard, then you can close this project because we're going to start a new one. So File, you know the drill by now. File, New, Java Project. We'll again call this, I'll call this Payroll 05A. All right, click Finish. Then come in. Again, you know the drill. Right mouse click, New, Package. Then come in again and create a new class in there that you can call Payroll. And then paste your other stuff in. Okay? So again, what I did was I took the Chapter 4 payroll program and made a copy of it, duplicated it in a new project that's called Payroll 05A. And the only reason we're doing this is so that we don't have to go and do a lot of retyping. That's all. All right, the first thing to look at, if you look up on the screen here, is these are our constants. Okay? It is considered acceptable, at least in the Java programming language, to take your constants and actually define them up above main. So define them at the top of your program. So that's what I'm doing. Quite often when you create program constants, the reason that you do that is that you're going to use the constants in more than one method. All right, so that's considered acceptable. But, okay, I'm going to put something in here, and this may or may not surprise you, okay? But when we look in here, first of all, notice, see how that got red? It says, wow, that's going to have to be static. So since I'm dealing with stuff in main, I'm going to have to put the word static in front of each one of these. We'll get rid of that very shortly. All right. So I put the word static in there. Now I don't have any warnings on the side anymore. But I don't want to do this. Look at how long main is. Main starts in line 14. It starts in line 14 and it ends in line 67. So main is about 55, almost 55 lines in length. We're going to change that right now. In fact, we're going to change main, okay? And why? Because the only thing we want to put into main, so I'm going to get errors when I do this. Don't worry about it. We'll get it all fixed, all right? But all I want to do in main is I want to call a routine that's called process employee, oops, you have to spell it right, employee records. That's all I want to do in main. I'm going to get a bunch of errors now. The first error I get is right here. Can somebody tell me why I'm getting an error right there? Right here. Why am I getting that? No. We haven't created a function yet that's called, or a method called process employee records. All right. You have to start learning how to modularize. And to learn how to modularize, because I had a student years ago, he loved just putting everything in main. I said, no, you have to start modularizing. So, well, how many functions do I need, how many methods, et cetera, do I need to write in this program? I said, well, at a minimum, main has to call another method. So he made main 2. And he had main call main 2. And he put everything in main 2. And I said, okay, you got me on that one. Not again. All right. So yeah, the first thing we're going to have to do here is we're going to have to come down after this and say public static void process employee records. And notice as soon as I do that and I put in my curly braces, that should go away, and it does. Now there's still problems because all this stuff is kind of hanging there right now in purgatory. It's not in any routine. All right? What some people like to do, and what I'm about to show you, this is totally a matter of choice. What some people like to do is they like to come in and, for example, put something like this in between each one of their methods. So you've got some kind of a delimiter. So you can tell exactly this method ends here and that one starts there. If that helps you, use it. If it doesn't help you, then forget I ever said it. All right? Again, it's just whatever is the most comfortable for you to be using. All right. So I do want to take and put some stuff in here, but not all of this stuff. All right. So I'm going to kind of pick and choose. So I'm going to come into my process employee records. Well, what do I want to do? All right. Well, each employee is going to have a first name, and each employee is going to have a last name. I think we'd all agree with that. All right. So each employee will have a first name and a last name. So I can grab these and then paste them in here. All right. Well, I'm going to have also all this other stuff, hours, rate, gross, I guess all of it. So I'm going to put it in there. Paste that in. You notice now this one's like, oh my God, now you're getting even worse here. Yeah, I am, because now I've defined these variables in here, so the only place these variables are known are within these curly braces. So if I try to reference those anyplace else, I'm going to get error messages. That actually, hopefully at least, should make some sense to you. But what I want to do in here is I want to add one more variable. All right, so I'm going to add double, and I'm going to call it tote gross, which I'll set again equal to 0.0. And that'll be total gross of all employees. Okay? But the idea is, please look up on the screen here. We said we've got 3 employees, right? So what I want to do is I want to be able to process these, and I want to do that 3 times. So that should make sense to you that what I'll want to do down here, in here, is I'll want to put a loop in here, not there. But I want to put in a loop. And what that loop will do is it'll do some of the work in here, and it'll call routines to do some of the other stuff. All right? So what I want to do then each time, okay, and I'm going to kind of do it the way Gaddis did it. So I'm going to come in here and say 4. Well, I need to have a counter, and I might use that counter someplace else. I don't know if I will or not. Do you all know this? If I do this, if I say int counter, you don't have to type this. If I say int counter equal 1, counter less than or equal to tote emps, which is my total number of employees, counter, I'm getting an error because I haven't defined it, plus plus. If I do that, all right, and I come in there and I define counter right here, it's only known within these curly braces. I can't use it outside of it. So if I want to use it outside of it, then I can't declare it here. I have to declare it out there. And I'm not sure right now if I'm going to use it out there or not. So what I'm going to do is I am going to come in here and put counter right at the top. So I'm going to say int counter equals 0. And that's all that it is. It's a counter. But now that I do that, now I get this message. All right? And I get that message because it's creating another one. And there already is one named counter. So I can do this. Well, there's 3 employees. So I have my choice. I can either count like a computer person would from 0 to 2, or I can count from 1 to 3. So I'm going to, since I initialize that to 0, I don't want to do anything with counter initialization. So I want to do that. I want to write it like that. And look at that. See if that makes sense to you. I have 3 employees. They're now going to be referred to as employee 0, employee 1, and employee 2. The reason I'm doing it like that, as opposed to setting counter equal to 1 and saying less than or equal to tote emps, is because when we get to chapter 7, that's on arrays. And when we work with arrays, they assume everything starts with 0. So if you assume right now everything starts with 0, and you start counting that way, you'll be better off. All right? So we can do some of the stuff in here if we want to. So I can still come in here, and where I put in that first name and that last name and the hours and all that other good stuff, I can still grab all of this stuff that we did in here previously. All right, so I can still grab all of that stuff. All right, all that, everything that was in that for loop. All right, to figure out the gross, copy, and I could still put it in here. Now, that's both a good thing and a bad thing. The good thing is, now that I don't really need it in here, that's going to get rid of a lot of my errors that were in there. All right, so I can grab all this stuff. And you notice that my errors are going down and down and down. So that's the good thing. The bad thing is all I've done is I'm calling this, I've kind of done a main 2. So this is kind of like main calling main 2, because now I'm doing everything right inside of here. So I literally could have this in its own method, 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 then this in its own method. Does that make sense to people? That actually would be a much cleaner way to write things. So what I'm telling you is, let's assume I have a program that's asking a person for 10 pieces of information. First name, middle initial, last name, address, city, state, zip code. All right? Those 7 pieces right there. Cell phone number, maybe social security number, and home phone, whatever. But about 10 pieces of information. Ideally, the way that you should write that is as 10 different routines. The problem with that is that we're human, and most human beings are inherently lazy. And they don't want to write it as 10 routines. They want to write it as 1 routine. It's all stuff about a person. All right? The good news as far as writing it as 10 routines, let's say for some reason I have a problem with a person's social security number, for whatever reason. Now I know right to the routine to jump to. And it's very short, very compact. I only have to dig through a few lines to look for what I'm looking for. You might say, yeah, but it's still not bad with 10 pieces. That's true. But then somebody else comes in and starts adding more information, and they put it in that same routine. Then somebody else does, then somebody else does. Now you've got a method that's 500 lines long. Don't think that doesn't happen. I have literally worked with C functions that are 10 or 15,000 lines long. And you're winding your way through it trying to figure out what's what, and it's nothing but confusing. All right. The other thing now, so what I'm doing here is 3 times, I'm telling it just like before, put in the first name, put in the last name, etc. Now, once I figured out the gross, now what I want to do is I want to say total gross plus equal gross. Does that make sense? That total gross is an accumulator. So what that's going to do is, as I figure out my gross for all 3 people, it's going to add them up. So if the first person made 500, then the next one made 600, then the next one made 700, it would be 500 plus 600 plus 700, or total gross would be $1,800. All right. Now that we've got all that, well, let's just at least grab this stuff and put that in its own routine, and we can do that. So now we're going to write one more routine in here that we're going to call display employee records. And in order to do that, we'll need to pass all this information. So first name, last name, hours, rate, and gross. And if I wanted to print out total gross here, also total gross. All right. So what am I doing right here? This is a call. This right here is a method call. All right. You have to understand that. Right now, I don't have a method by that name, so I have to create one. The easiest way to do that is to just literally grab everything that's in here, other than the semicolon on the end, and come down here and basically what we have to say public static void, and now paste it in. Put that there. I'll need another curly down here someplace. All right, but you'll notice my errors are going down. All right, so display employee records, display employee records. So what's the problem here? Well, I didn't say string, first name. Let me put each one on its own line so you can hopefully see what's going on here. String, last name, double hours, double rate, double gross, and double tote gross. All right. So again, we're coming through here, we're modularizing our program. So now for each one of those employees, all right, we're going to have to come in here and print out their information. And move this stuff over a little bit now, which will also make it a little easier to read. Now, I don't call it LCV in here, right? It says employee number LCV. Okay? I'd either have to pass that, that's the counter. I'd either have to pass that or just not put that in there. I'll just leave it out for now, just so you see this. Hopefully you see this program running in action in just a second. So what's left? It's got an error here, and it's got an error there. Both the errors that are left are right here. So I think if I grab that thing that says end of program, just remove it for now. All right. And it probably does have one too many curly braces in here. Okay. Now, was this a good example? What I wanted to show you was we took main and just changed it to a single call. Then we still did the majority of our work in that single call. We did our processing in there. When we got all of the stuff processed, we did our output in yet another routine. So just to show you that, all right, and I'll save this out there so you can take a look at it, all right? But it should work, should, being the opportune word, the exact same way that it did before. There's all my stuff. Next person. And the next person. And you see all that stuff, and I never printed out my total gross. That's why that's not in there. All right? So we actually could, and a cleaner way to do this, this is displaying each employee's records. I think you'd all agree with that. What I really should have done is I should have just grabbed this, and I should have, at the very end, I should have put in, after we called display employee records, I should have called display total gross. And then just passed in tote gross. Again, I'm going to get an error because that routine hasn't been written. So underneath this routine, I'd have to write another routine that would say public static void display tote gross. I think that's what it was. Double, we'll call it TG this time because it doesn't have to be called the same thing. And then we would print out the total gross. I'm going to get an error because I'm using formatting, so I'll just get rid of the formatting. All right. Oh, I said display total gross, and down here I called it display tot gross. All right. Now, just so you can see this, now when I run it, again, keep it simple. 10, 10 gives me 100. All right. Gives me 400. All right, 2750 for the overtime. And now I've got system.out, so that's displaying it. There's each employee. Down at the very bottom, there's the total gross pay. I could have done that also as a message dialog. But the point is, what hopefully you're starting to see with this is what we've done is we've taken something that was in, everything was in here, and we're starting to segregate it out. So here's one routine, which is still doing most of it. All right. But then we're calling another routine to each time through, and then we're displaying our total gross. In fact, when you look at this, this is good. I made a mistake. All right. There's the for loop. So we're doing this 3 times. Should we be displaying the total gross 3 times? I don't think so. So I should really take that line where we're displaying the total gross, and I should move it outside of the loop so it only displays once. Because what we had previously is it was displaying the total gross every time. 100, then 100 plus 400, which was 500, and then plus 2700. So you can see it works. Maybe I'd want to leave that in there when I'm testing to make sure that my logic is correct. But now if I grab and put in the same stuff, what you're going to notice is that's only going to print out once. And again, I can grab this now. Use the J option pane. All right, and do it like that, which will make it look a little cleaner. And there's the total gross pay. All right. So you can take any program that's been written as just one method and break it up into multiple methods. And that's what you should be doing. All right. We're going to take a break and we're going to come back and look at this in a little bit more depth. I'll grab this whole thing that I've done here and just throw it out on the system. In fact, what I'll try to do during the break is take each one of these and put them into their own routine. All right. So you can really see it modularized. All right, so let's take a break. Sorry, it's a little late. Let's come back at 11:15, please.